Alright guys, so today is going to be about physics bodies and collisions in Swift. So what I went ahead and did is I just added this robot, this ground is going to be, or this little block right here is going to be the ground kind of, and then I have another robot, robot 2, and what I'm going to do is robot 1, I'm going to show you how you can do everything just using kind of the drag and drop SKS, and then robot 2 I'm going to try to do everything in code, so that's why he's not showing up right here. Alright, so let's just get started right away. So when you go down here, you'll see something physics definition and body type. There's bounding rectangle, bounding circle, and alpha mask. So bounding rectangle, as you can see, just kind of makes a rectangle box around the guy. That's his physics body, so anything that touches here basically collides with him. And then we're going to move on over, and we got bounding circle, and this creates a circle around the guy. This is almost always way bigger than what you actually need, unless you're working with a sort of circular object. But the one that you guys will probably be using the most in your game development is going to be this one right here, alpha mask. And what alpha mask does is that kind of maps kind of the texture of the image, so it just outlines the image and assigns the physics body accordingly. So now over here in code, I have robot 2, and I suppose I'll make this a little cleaner right here. So robot 2, I just said, is going to be an SK sprite node that's the same size as robot 1, and a little bit to the right of him, and its name is going to be robot 2. Now, to do what I just did over there in the drag and drop, you're going to say robot 2 dot physics body equals, and you're going to say sk physics body, and now from here you have a few choices. So circle of radius, using this one right here, will give you kind of that circle, so you could do something right here like robot dot size dot width divided by 2, and because it's the radius is why we have this divided by 2, and this kind of will create a circle around him based off of his width. Otherwise you can say robot size dot robot 2 dot size dot height, and that will create a circle around him, kind of going the tall way. Otherwise you can say sk physics body and rectangle of size, you could say cg size, and in here you could set a width, so here you could say, robot dot size dot width, robot dot size dot height, and that will kind of create that bounding rectangle around him. Or the one that you're probably going to want to use, that alpha mask one, you're going to go down to the one right here that says texture and size, and for SK texture you can just say robot 2 dot texture, and size you can just say robot 2 dot size right there. And if you gotta include that exclamation point right there. If you don't set the robot 2 dot size right here, it'll just default to whatever the default size of the image is. In my case, it's this robot right here that's 129 by 250. Okay, so moving on now, we're going to go back into here. So now they both kind of have this one that's kind of just wrapped around their texture a little bit. So we'll move him back over here a little bit. And going down the list now, the next thing is these 4 checkboxes: dynamic, allows rotation, pinned, and affected by gravity. Now, dynamic, you almost want this checked for almost everything. This just means it can interact with other objects, it can move, it's not stationary. Allows rotation, that's pretty self-explanatory. Say, for example, you shoot a projectile that hits the robot in the head right here. He'll start rotating, otherwise, or if you uncheck this, then he won't rotate. And then pinned just means he's like pinned to this location and he will not move no matter what happens to him. And affected by gravity, that's pretty self-explanatory. If you're on this main screen here, you can see gravity. I set mine to -10. I think it's -9.8 by default. So that'll just affect if he's affected by gravity. Now to do all those in code, it's more or less the same thing. So you just say robot2 dot physics body, and here you can say dot is dynamic, and this is either true or false. Otherwise you can say, and that's true by default. Otherwise you could say dot pinned right there. Otherwise you could say dot affected by gravity and allows rotation. So they follow the same naming conventions, and these are all true false values that you can just set like that. But we're going to just leave them at the defaults for now, so I won't put those in there. And you need a physics body. If you don't assign it like this or using the user interface and clicking physics body, your object will not collide with anything or generate any notifications when it touches anything. You also can't apply impulses, and you can only move it directly. So you want a physics body on almost everything in your game if your game involves physics or collisions or contact. So moving on down the list right now, we have these four things: friction, restitution, linear damping, and angular damping. Now, friction is, for example, if I made a ramp for a ball to slide down, like so, and I would have put a ball right here, friction just kind of affects how fast that ball rolls down the hill. I won't actually, make this and test it out, but if I set a really high friction for either one of these two things, my ball or my ramp, it will go down a lot slower, and a lower friction will make it roll down faster. Pretty self-explanatory. And then this next one right here, restitution, that's kind of like bounciness. You can think of it as that way. So a higher restitution will make your object bouncier, and a low restitution will make these objects almost like Velcro, just like stick and then not move or jump or bounce or anything after that. Linear damping and angular dampening, you don't have to worry about those too much. Those are more complex ways. Those are just like how the acceleration and the velocity of friction and restitution affect each other and how it moves through air with gravity and stuff. But you can just leave those at the defaults. This one right here, mass, that's kind of self-explanatory. So if you have a higher mass, for example, and you collide with something that has a smaller mass, the higher mass object will more likely keep going the same way that it was. Kind of like when you're driving and a bug hits your windshield, your car has a lot bigger mass, and it's just going to keep going, and that fly is not going to keep going. So that's kind of what the mass does. And then to set these 5 things in the code, it kind of follows the same thing. So you could do something, like robot2.physicsBody, and you could say dot friction, and this is going to be a value. So I could say like 0.5 or something like that. And then you can set dot restitution, and that's kind of the bounciness of the physics body as it says right there. Or otherwise you can set linear dampening and angular dampening, but like I said, you probably won't worry about those. And then to set its mass, robot.physicsBody.mass equals 3.14, and that's pretty self-explanatory too, what mass does. Alright, so that's how you can set those in code. Now, moving on, the last few things right here: category mask, collision mask, field mask, and contact mask. Now, what these are for, this is kind of getting in, oh sorry, I skipped initial velocity. That's also a pretty self-explanatory one. Say you have a cannon and you're shooting a ball out of it, you might want that ball to have an initial velocity, so you can set its initial velocity x and y component. Now, moving on to the category mask, collision mask, and contact mask, you don't really have to worry about field mask too much. So now what these all do is category mask is going to be kind of the name of your physics body. You can think about it that way, kind of like your ID of the physics body. collision mask is going to be what you want to generate collision notifications with. So, for example, if you have a player hitting, like a bullet hits a player in your game, you care about that collision, and you want to do something with that. So you want to make sure you have their collision mask set. And then for contact mask, that means they will actually collide with each other. And sorry, I accidentally reversed those. Collision mask is they will actually collide with each other. Contact mask is they will generate notifications with each other. I don't recommend using the user interface because it doesn't really work how you'd expect it to using the user interface. So we're going to actually set these in code, and I'll show you how we can do that. So going through, the first thing you're going to want to do any sort of collision or contact handling is you're going to include this right here, SK Physics Contact Delegate, right, in your game scene class. And then in your did move to view, you're going to say physics world dot contact delegate equals self. And this line basically just says that this class right here is going to handle your collisions. So now you can add this function did begin, and this one right here, contact SK physics contact, just like that. And now to grab the two bodies that collide, this is going to be called every single time any two bodies collide. So what you could say is let body A equals contact dot body A dot node, and sometimes I like to put as SK sprite node if you're using those. Otherwise you could set the dot node, and let body B equal contact dot body B dot node as SK sprite node. So that's going to handle that right there. So now it's completing that, we didn't use those yet. So now as far as generating collisions and handling what happens when things touch each other, so we have robot 1 and robot 2 that we're going to distinguish between. So we're going to start off and we're going to say robot robot 1 dot physics body dot, and here we're going to say category bit mask, and we're just going to set that to 1. And then we can say robot 1 dot physics body dot collision bit mask equals 2, and robot 1 dot physics body dot contact test bit mask equals 2. And now what this basically says is robot 1 has its physics body has a name basically of 1, and anything that has a name of 2 for its physics body, it will both collide with in the real world with this collision bit mask, and it will generate notifications, aka call this did begin function with this contact bit mask. So over here we're going to say robot 2 dot physics body dot category bit mask equals 2, and now that's kind of giving an ID of 2 to our robot 2 body. And we can say robot 2 dot physics body dot collision bit mask equals 1, and robot 2 dot physics body dot contact test bit mask equals 1. And that'll just guarantee that these always kind of happen like that. Okay, so once you add these two lines right here, you can go ahead and just say real quick, if body A dot name dot contains robot. Here, you know what? I'll show you the best way actually. So right here you can say if body A dot name equals robot 1 and body B dot name equals robot 2, And then right here you can say else if body B dot name equals robot1 and body A dot name equals robot2, like so. And then right here we'll just say body B dot remove, not all actions, remove from parent, and here we'll say body A dot remove from parent. So now what this will do is whenever the two robots collide, it's just going to remove, sorry, I gotta, oh, sorry, I need double equals there. This is just going to remove the one on the left. So as you can see, another way that you can do this is you could say function robots collide, and you could say, you know, robot1 is a SK sprite node, robot2 is an SK sprite node, like that. And then in here you can call robots collide, and then here you'll say body A, here you'll say body B, and then you can copy this function, copy this function right here, and then switch around body B, body A, like so. Sorry, that was kill that. And now right here you can just say robot1 dot remove from parent, just like so. So now when these robots collide, you'll see that the one on the left will get removed once the two robots collide. So I'm going to move him, and it's the one that there we go. And there, he's gone. So that's it for physics bodies and collisions. Make sure you hit like and subscribe. If you have any questions, leave them down in the comment section below. And that's all.